So the model that we can use for dividing fractions is comparing the two fractions as a ratio. So when we talk about divide, we have 2 divided by 3. Well, we can compare the 2 to 3 as a ratio. Okay, so 2 divided by 3 is same as 2/3 as a ratio of 2 parts to 3 parts. Okay, 5 divided by 8 can be shown as a ratio of 5 parts to 8 parts, or 5/5, or 5/8. So when we divide, we are essentially treating two numbers, comparing two numbers as a ratio. So when I do this with fractions too, we're going to have the same. So if I have 5 divided by 6, well, 5 divided by 6, we can just show it as 5 parts compared to 6 parts whole. Okay, so 5 divided by 6 is going to give us a 5/6 fraction. The ratio of 1/3, 1 to 3 can be shown like this. Okay, 1 part to 3 parts. If I want to show this as 1 part to 3 parts whole, I can show this in a fraction picture. We can write this as basically our fraction bar, and we have our 1 part. Okay, that's our part compared to 3 parts whole, so it's going to be our fraction bar picture like this. As a division statement, it's going to be 1 divided by 3, which is equal to 1/3 fraction. And everything then is consistent, okay, as a ratio, as a fraction picture, as division, as a fraction. So when we divide fractions, the model that we want to use for visualizing this, okay, is to show it as a ratio. So when I do 1/4 divided by 1/2, I'm going to be showing it as a 1/4 fraction compared to a 1/2 fraction as a ratio. So there's my 1/4 to 1/2. Okay, so I'm going to show that as a ratio. Well, this is 1 part to 2 parts. Okay, so if this is 1 part to 2 part, we know that 1/4 compared to 1/2, then it's going to be 1 part compared to 2 parts. Okay, so the answer is going to be 1/2. So 1/4 divided by 1/2 is 1/2. And we have a strategy now that of multiplying by the reciprocal, and this should confirm it. Okay, and this is visually true, so it must be mathematically true. Okay, and this also then justifies how we can use this 1/4 divided by 1/2 can be translated into 1/4 times. So if we do an opposite, we have to do another opposite, okay, which is flipping the fraction, and we get 2/4, which simplifies to 1/2. So that confirms that. Okay, but the picture doesn't lie, so this has got to be true. This is just confirming that this actually works. So again, if we take a look at these ratios, 1/3 to 2/3 ratio, okay, if I take a look at this picture here, I'm comparing this 1/3 fraction to 2/3. Well, if I look at the picture then, if I combine them, this is really a 1 to 2 comparison. Okay, if I put them together in a fraction, if I put the red fraction on top, the blue fraction represents my whole. Okay, that's going to be my denominator. And the red fraction represents my part, so I end up with 1 part to 2 parts whole. Okay, so the answer should be 1/2. And again, I can confirm that my strategy of changing the divide to times, doing an opposite, and then doing another opposite of flipping the second fraction, I can see that times 3 divide 3 cancel out, and sure enough I get the correct answer of 1/2. Okay, so we need to be able to do this, right, algebraically or symbolic, what we call symbolically, but we also need to be able to make sure that we understand this in terms of a visual picture, and we have a model to do this. And the easiest model we have is probably going to be the ratio model, comparing two fractions as a ratio. If you want to use the area model, that was another model that we use. So if you can use the area model, that's fine as well. That tends to be a little bit harder. So my recommendation is to stick with the ratio model.